Today's math lesson is going to be on multiplying decimals that are both positive and negative. And really, I don't feel that we need a full lesson. You know your multiplying negatives rules, which apply to all numbers, whether they're whole numbers, fractions, or decimals. So more or less, this is a review of multiplying decimals with a couple pointers thrown in there. So the only thing I'm going to really quickly review is what are your rules when you multiply positive or negative numbers. And to do that, I'll use the tic-tac-toe board that some people know. And on this board, if you put a P right down the diagonal, P for positive, and then everywhere else you fill in an N for negative, then you have your multiplying rules. And here's how it works. A positive times a negative is a negative. In the second row, a negative times a positive is a negative. And in the third row, a negative times a negative is a positive. So keep those rules in mind as you're doing multiplication today. So when you multiply decimals, you don't have to line up anything. All you do is you treat the numbers as if they were whole numbers. So that means temporarily forget that they're even decimals. So we're doing 25 times 36 and multiply like you normally would. So again, forget that there's a decimal there. We will revisit the decimal at the end of the problem. I'm pretty sure you know how to multiply, so I'm going to skip through all the steps that you'd take. At the end of the day, we would get 900 for this answer. Now, 2.5 times 3.6 is not 900. Clearly, we need a decimal here, and here's how you do it. You go back to the original numbers in the multiplication problem, and you say, how many decimal place values are there in each number? So in the first number, there is one place value for the decimal, and in the second number, there's one place value as well. So in total, there are two decimal place values, which means in your final answer, you need to count from the right, the furthest right, two spaces. 1, 2, and that's where your decimal will be placed. So the final answer to this number is 9, not 900. And since I have a negative times a positive, my final answer is negative. So 2.5 times 3 6/10 is equal to negative 9. Also, if we rounded this is about 3, and this is around 3. 3 times 3 is 9, so our answer is definitely reasonable. So there you go. The only other problem I wanted to show was if you have multiple numbers that you're multiplying, it's not just two numbers, always remember, when you are multiplying, you are allowed to multiply in any order that you want. 2 times 3 is the same as 3 times 2. The order does not matter when it comes to multiplication. So if you're looking at a problem with three numbers and you say to yourself, oh, I think it would actually make more sense if I did the negative 8 times the negative 5 first, for whatever reason, you can do that. So actually, let's treat it that way. I'm going to do negative 8 times negative 0.5. The reason I'm doing that is it's mental math. 8 times 5 is 40, but there's one decimal place, so it's 4. And a negative times a negative is a positive. So these two numbers multiplied together equal positive 4. So now I've got positive 4 times 0.09. And I did mental math for the most part. And now to multiply these two numbers, you forget that there's a decimal, so it just becomes 4 times 9, which is 36. And then this number has no decimals. This number, 9/100ths, has two decimal place values, 1, 2. So my answer has to have 1, 2, two place values. So the final answer to this problem is positive 36/100ths. And a negative times a negative is a positive, and then a positive times positive is a positive. There we go. Last one, little word problem action, because word problems are good for you. A school record for the 40-meter dash is 15.24 seconds. Predict the school record after 15 years, when the school record decreases by about 0.06 seconds per year. So every year, people apparently are getting faster, a little tiny bit faster. They increase their speeds by about 6/100ths of a second. So that means if the record was 15.24 the first year and it goes down by 0.06 after 1 year, that would be 15.18 seconds. But we're not going down 1 year, we're going 15 years, and it would be a little bit silly to sit here and subtract 6/100ths 15 times. So instead, what we could first do is find out how much it's going to decrease over 15 years. So every year for 15 years, it's going to decrease, and a decrease is negative. It's going to decrease by 6/100ths of a second. So in total, my decrease is going to be 15 times 0.06, which is negative 0.9. So 9/10ths of a second, which might not seem like a big number, but when it comes to sports and running in particular, if you can shave a second off of your time, that's almost a second. That's a lot. That's a lot. Especially when it only takes you 15 seconds in the first place to run the race. So now let's answer the question. 15.24 was the school record, and in 15 years, we're predicting that we're going to shave off or decrease by 9/10ths. So in total, the new record we would predict after 15 years is going to be 14.34 seconds. And let's see, this is where we had multiplying with a negative number. We decreased by 6/100ths of a second for 15 years. We found our total decrease, and we took that off of the original time. And that's it for today. So multiplying negative decimals shouldn't be super challenging. Take your time. Make sure you're counting your place values at the end of the problem. And also take the time to make sure that your answer is reasonable and makes sense. Otherwise, if you have questions, reach out or ask on the Google Meet, and see you next time. Bye.